So we have one of the second round feasibility projects, and we basically were just about getting started properly in terms of the field work when COVID struck. So there has been a hiatus in the middle of all of that. But basically what we are doing is we're in a rural catchment not far from Balrudry. And there's a mix of sensor development as well as looking at different techniques for communication, because while this particular catchment that we're looking at is quite close to a reasonably sized town, there's quite a lot of kind of communication black spots. So we're basically piggybacking onto LoRa and LoRaWAN, but we're also having to have various repeaters, and we're also have a small contract with a communications company in terms of transmitting the data for us. So this is the team in Glasgow, and our partners are the Scottish Environment Protection Agency and the Innovation Centre for Sensing and Imaging, because they have also been developing some new sensors which we have now managed to deploy. The whole point about the feasibility project was to instrument, as I said, this small rural catchment to effectively develop a system that might provide information for farmers, particularly around abstraction from the common water course that runs through their lands for irrigation. So we've been installing new sensors and supplementing a couple of existing SEPA sensors to look at water level, soil moisture, humidity, etc., etc. And as I said, to really fundamentally test the technology about communicating the data back, because as I said, although we're not that far from civilization, it's actually really surprisingly patchy in terms of the communication. Because we had this hiatus due to COVID, the SEPA team weren't out in the field for a number of months. And as I said, we've been a bit held up in terms of getting the sensors deployed, but we now have, I think, something like 30 sensors deployed in this catchment. And the data are effectively streaming back to us now. We are also linking it with satellite data, with the Met Office data. And as I was saying to Matt earlier in one of the chats, we've just started looking at the Cosmos data from Balrudry, which is the nearest Cosmos site. So while we couldn't do any field work, one of the postdocs involved has been working quite hard to develop an app which SEPA can then deploy to visualize the data as it comes in and to effectively detect events and anomalies, and which can then be fed back into the SEPA system. And in particular, it will feed back into SEPA's, if you like, drought monitoring system. And so we're really very excited about that, because that wasn't originally the initial, if you like, application that we'd been focusing on. But because of the COVID hiatus, we had to kind of find a few other things that we could be usefully doing that were helpful both to local farmers and to SEPA in particular. So the pictures on the right hand side are from one of our SEPA colleagues, just showing you the site and some of the equipment that's gone out. As I said, it's quite rural. I think they're showing some fairly flat bits, but there's also quite a few extensive dips and troughs and hills. And that means that we academic statisticians haven't been out in the field with our Wellingtons on, which was an original plan, because we had been going out to observe. The communication with the local stakeholders hasn't taken the form that we expected. We were going to have 1 or 2 meetings with them, again facilitated through the SEPA local office, but that hasn't happened due to COVID. But because SEPA have been working in this catchment for a number of years, and it's one of their priority catchments, the local farmers are very supportive of what we're trying to do, and actually very excited at the prospect of getting something that they can use themselves. So that's the project as it currently stands.
So our project, which is called the Digital Environment for Water Resources, is the main PI on this project is Marion Scott, who can't be here today. So I'm in a way representing her. So our project is based around the creation of a network of river water level and soil moisture sensors in a remote and rural catchment area, which is the Elliot Water in the northeast of Scotland. And really our aim is to improve the understanding and regulation of water abstraction in that area. So suppose within the digital environment, the wider digital environment team, our focus is more on environmental instrumentation, data streams, and information flow, and how this helps to inform management. So as part of our project, we have a new sensor pod that is being developed by Sensis that is combining several probes, but a large part of the challenge, which is to be addressed by our current project, concerns the communication of the data from the sensors, from the field back to ourselves for analytics and modeling. So at the current time, we are kind of testing different communication approaches because we are trying to imagine this project as an end-to-end project with our sensor boxes that are being built by Sensis and SEPA and being installed by SEPA, and communications being developed by Sensis, and then this data being kind of developed, this data being sent to the cloud, and then us at the University of Glasgow providing data quality assurance and modeling. So we have quite a lot of teams doing various different things, you know, kind of building the sensors, deploying the sensors, ourselves producing or like quality assuring the data and providing some modeling. So really the relevance of the project is more or is very clear to SEPA because they wish to test and trial sensors in that area as a remote environment because they wish to do this on a larger scale. So this is really like a trial project for them. And their aim is to make improvements to their drought management and industrial use of water system. We are currently at the stage where we have deployed several sensors, and we have been receiving real-time data ranging from river level, soil moisture, temperature, and humidity. And we started monitoring this data and quality assuring it, and we are still developing and deploying some sensors and kind of dealing with some problems in the field because some sensors are not quite working well, and it's quite a challenge to get people out there because it is a remote area. Every time something goes wrong, it's quite a challenge to send someone in the field to kind of deal with the problem or to check what the problem is in the first place. So more on the kind of modeling and quality assurance side of the data, we have created like a web application that allows us to see the data in real time, download it, and have it ready for modeling. And one thing that we have started working on is developing a criteria, which is called the Hutton criteria, which is a tool that helps identify high-risk periods for disease development in potatoes, which is something that farmers are very interested in. Farmers in the area are very interested in. And because basically this is kind of like an early warning system to let them know when their crops are in danger and they can implement whatever security measures they have to protect their crops. So this is something that we have started working on, and we have some early kind of some early numbers that can already help farmers in the area. And another kind of modeling project we are working on is one that aims to combine different soil moisture data sources from the Cosmos network and from the Copernicus land service, and also some satellite data. And we plan to kind of fuse all these data sources and produce a soil moisture map of the area that is more detailed than can currently be provided. And again, the purpose of this is to kind of inform farmers, or inform farmers in the area about the quality and the moisture level of their soil.